Okay, for this video lesson, this is day 1 of 2.2. We're going to look at end behavior of graphs. A lot of this really is kind of review, but basically what we're going to see is how the degree or the exponent for an equation affects the graph. And we're going to observe the end behavior. What I mean by end behavior is what happens to the graph when you go to the left forever, and what happens to the graph when you go to the right forever. Does the graph go down or does it go up? Okay, pretty simple here. Now what you could do right here, you really should know 1, 2, and 3. Those are basic shapes we work with. Maybe what you could do right now is you could stop the video and just graph this, y equals x to the 4th, and see what that looks like. Okay, so you can stop it now and see what that looks like. Okay, hopefully you just did that. And let's look at the graph for all of these. I know if I graph y equals x, let's put this in a different color. Let's put this in red. This is just our line. Okay, so you can see to the left this goes down, to the right it goes up. I'm going to put these arrows here. To the left it goes down, to the right it goes up. Let's see, the next one is just your parabola. I'm just going to put this all in one color here. Let's see here. Okay. Now this is our parabola. Now you can see to the left and to the right they both go up. So I'm going to put to the left it goes up, to the right it goes up. X cubed, we know this shape. This is the S curve. It looks like this. So now this is like number 1. To the left it goes down, to the right it goes up. So I'm going to put this here. To the left it goes down, to the right it goes up. So you know that without even using a graphing calculator. If you did y equals x to the 4th, it's going to look just like number 2. It's going to look just like a parabola. It'll probably get more narrower, but I'm not really concerned with that. All I care about is the end behavior. So these both go up. So that's the end behavior there. So at this point, you should be able to see that for 2 and 4, if the degree is even, okay, if this exponent is 2, 4, 6, 8, or 10, then the end behavior is that they're both going to go up. Now, if the degree is odd, like number 1 and 3, if your degree is odd, right, if that's 3, here it's assumed to be x to the 1st, then it goes down to the left and up to the right. Here it goes down to the left, up to the right. Okay, a lot of this stuff you already know. Now, if I were to take, I'm going to take number 2. I know it gets a little messy here, but I'm going to take this. I'm going to make it negative x squared. You know this from graphing the basic shapes. Now the parabola looks like this. It goes down left to right. So then it would flip everything. So it would go down to the left, down to the right. Okay, I'm just going to erase that part. Now I'm going to look at the S curve. The S curve, as we should know, if I put negative x cubed, well then this flips. So now the graph goes down left to right. So the end behavior goes up to the left, it goes down to the right. Okay? That's basically the whole gist of this lesson. That's it. All you have to look at is your degree, your highest exponent, and you know whether the two sides go up or down. Okay, so let's sum this up. Okay, if the degree is even and the leading coefficient is positive, that means the leading coefficient positive, that's the example for those 4, because it was y equals x squared, y equals x cubed, y equals x to the 4th. The leading coefficient was positive. So that it's real easy. If the degree is even, here's your end behavior. They both go up. So you can just put arrows for it. If the leading coefficient is negative, well that means it's this case. That's where the parabola goes down, so then they both go down. When the degree is odd, right, this is like our S curve. We can kind of use this to cheat. Whoops, that's actually when the leading coefficient is negative. So when the degree is odd, this is what the S curve looks like. So if the leading coefficient is positive, this is what we get. It goes down to the left, it goes up to the right. Then when the leading coefficient is negative, now it looks like this. It flips over the x-axis, so to the left it goes up, to the right it goes down. Very, very, very simple. Okay, I don't even need to graph these. I just look at the highest exponent, and all I'm going to do here is describe the left-hand and right-hand behavior. I'm just going to represent them with arrows. That's it. Okay, if I do the first one, I see right away that this 4, that is the highest exponent. The leading coefficient is positive 1, so it's going to look like a parabola. They're both going to go up to the left, up to the right. Okay, for number 2, they try to trick you into thinking that that 4 is the degree. Usually the degree is written first, the highest exponent, but in this case, the highest exponent is written last. Now this is going to look like the S-curve, but now it's a negative in front, so the S-curve is going to look like this. So this goes up to the left, down to the right. Okay, number 3, highest exponent's 3, leading coefficient's positive 2, so now it looks like a normal S-curve. It looks like this. So it goes down to the left, up to the right. And then number 4, well, obviously 4, that's the only exponent there. So they're either going to go both go up or both go down. Leading coefficient's negative, so they both go down. Okay? Very, very simple. 5, 6, and 7, now these are written differently. You might think that if you look at 5, the degree is 2. But the reason why it's not is you have to multiply these out. Now, you don't have to FOIL it. You know if you FOILed out the x plus 1, you're going to get an x squared. And if you bring this down, if you multiply this by the x, you're going to get x cubed. So really, when it's factored out for you, you have to add these exponents. 2 plus 1 gives us a degree of 3. And since all these x's were positive 1, it looks like an S-curve. It's going to go down to the left, up to the right. Okay, number 6, again, if you multiplied all these out, you would add these exponents. I'm going to put D for degree is 4. Let's see here. Now, if you square this negative, that gives you positive x squared. And then this x, when you square it, that gives you positive x squared. So what I just proved that when you multiply it, it gives you positive x to the 4th. Your leading coefficient's positive, so it's going to look like a parabola that goes up. So this end behavior goes up to the left, up to the right. Okay, when we do 7, I'm going to put D for degree. Again, it's factored out, so I have to add the exponents. So 3 plus 3, my degree is 6. So since it's even, I know the end behavior, they either both go up or they both go down. Now this one's a little bit different. Now if I look at this right here, again, I don't have to FOIL everything out. I know if I cube that negative x, I'm going to end up with negative x cubed. And then if I cube this x, it's just x cubed. And then you know if you multiply these together, you have a negative with it. So now I prove that it's going to flip, so the parabola is going to go down. So the end behavior goes down to the left and down to the right. Okay, so easy thing to sum it up. If you know what your highest exponent is for the polynomial, if it's even, they either both go up or both go down. If it's odd, it looks like an S-curve. One side goes down, the other side goes up.